Hello there, my name is Alyssa Wilson, and I'm going to be presenting on giraffes' long necks. The first adaptation that giraffes embody is that of increased arterial pressure. This increased pressure is provided by a specialized heart and is sufficient with the help of a specialized jugular vein scheme. First, I'll talk about a study that looked at the structure and processes of the giraffe heart. The giraffe heart produces increased arterial pressures as compared to other mammals that allow normal brain blood flow. This is not due to an enlarged disproportionate heart, since their hearts follow the appropriate ratio of about 0.5% of body mass. However, it is produced by an increased systemic vascular resistance. This conclusion is given because giraffes have a predicted by scaling measure of ventricular wall stress, and that their hearts are not out of bounds in reference to scaling for their body size. Given an appreciation of Laplace's law, the systemic vascular resistance might be increased by having a lower ventricle radius and a thicker ventricular wall. Secondly, the other main adaptation for increased arterial pressures is a specialized jugular vein system. It should be pointed out that the jugular vein is an important main vein in the neck. The pressure in the arteries is thought to be correlated to the hydrostatic pressure generated within the jugular vein. That jugular venous pressure is created by tissue pressures surrounding the collapsible vein, and the fact that there is no siphon benefiting flow through circulation in the cranial area. Furthermore, baroreceptors regulate systems so that this jugular venous hydrostatic pressure can overcome gravitational effects. The positive countergravity jugular venous pressure helps overcome gravity by reducing the effort of the arterial blood to go up the neck to the brain. A representation of pressure in the jugular vein through a giraffe neck can be seen in Figure 1 in the bottom left corner. Moreover, there is a viscous resistance in the jugular vein. This is caused by the viscosity of the blood and the inflexibility of the tissues around it. Blood is 4 times more viscous than water, and the tissues are made of fairly stiff collagen in the giraffe. The second adaptation that makes high arterial pressure non-detrimental to a giraffe is that their organs, specifically the kidney, is tolerant to the high pressure. For one, the kidney is able to tolerate the large arterial pressures by having high renal interstitial pressure. This keeps the blood inside the capillaries. And having a low glomerular filtration rate, also known as GFR. This is important for the kidney since it is at heart level. Surprisingly, there is no hypertension-related damage to the kidney. Furthermore, GFR is based on Starling forces, which include hydrostatic filtration pressure and the opposing oncotic pressure. Normally, GFR would increase with blood pressure. Additionally, interstitial pressures within Bowman's capsule are the interstitial pressures that we're talking about. The high renal interstitial pressure is accomplished by Bowman's capsule being thick and durable, with a valve at the junction of the renal vein and the vena cava. You can see a dissected giraffe kidney in the upper right-hand corner, if you're interested in size and structure. I'd like to give you a summary of what is included in this poster and some conclusions from that info. 1. Giraffes have abnormally high arterial blood pressure, but it does not impede success in their environment. 2. Kidney adaptations allow giraffes to have high arterial pressure that is required to supply blood to their brains without damaging their kidneys, which are also vital for survival. 3. Jugular vein pressure allows energy to be conserved and blood being pumped up to the neck to the brain. 4. Systemic resistance in vasculature is needed to compensate for low cardiac output in order for high arterial pressure to exist. Furthermore, some future directions for research and even personal interest include the following. For one, are there other organs in giraffes that are adjusted to high arterial pressure? If not, are there repair mechanisms for those organs? Secondly, are there animals with disproportionately small necks that have adaptations opposite of giraffes? Also, what evolved first, these coping mechanisms or the long neck of the giraffe? More on that idea. If their long necks came first, did all the adaptations come in rapid succession or slowly one at a time? Thank you for listening, and I hope you enjoyed the information on giraffes.